can be divided into two types. We have fibrous proteins. We have the word fiber-like. Fibrous protein and globular proteins. Globular, circle, globule, globular proteins. Okay. Now, since proteins are made up of course, the amino acids, so as their building blocks. Now, what are these amino acids? Now, they are compound, or say an amino acid is a compound that contains both an amino and the carboxyl group. So this is actually the structure of an amino acid. This is the carboxyl group and the amino group. Now all amino acids have the same structure except for this R. They all have the same structure except for this R. So they just vary in the R. So you have here the R. So you have here the carboxyl group, the amino group, and then you have the R. Now alpha amino acid. Now an amino acid in which the amino group is on the carbon adjacent to the carboxyl group. So you have here the amino group lies adjacent to the carboxyl group. We call this as the alpha amino acid. Meaning, very adjacent to the carboxyl group lies adjacent to the amino group, or vice versa. So this is an example of an alpha amino acid. Now, although alpha amino acids are commonly written in an ionized form, when we say ionized, meaning na I charged, meaning with charge, ionized, with ion, positive or negative ion. But usually it is written in an unionized form. Now, they are more properly written, however, in a Zweiter ion. When we say Zweiter ion, you have here, so this is unionized form. You cannot see any charge here. So this is unionized form. Now this one is a Zweiter ion. Meaning, when you say Zweiter ion, it's a compound with positive charge. So you have here the positive charge and a negative charge. So you have the amino group, the carboxyl group in an ionized form. So this is Zweiter ion. And usually, when amino acid is present in water, its structure is in its Zweiter ion. Its form is in Zweiter ion. So you could see the positive group and the negative group. So you have here the positive ion and the negative ion. Okay? Now, so you have here some examples of amino acids. So this is the Fischer projection for amino acid. What projection is that? So you have here the Fischer projection of an amino acid. So you have here, if the amino group is on the left, then we call it as L amino acid. Gani, amino. L, left. Always na lang siya. Ang last time sa carbohydrates, kung ang OH or hydroxide ion is on the left, sa stereocenter, the carbon before the fifth carbon, so you can describe it as the L. But if it's on the right, then we have the B amino acid. Okay? So that is Fischer projection. Okay? So like this, so this is the D-alanine, this is the L meaning the amino group is on the left. D on the right. Glyceraldehyde. We have glyceraldehyde.
Right.
Okay, so this is our example. No? Throwback sa tuwang carbohydrates. So the same. And yung OH, say ang OH nasa right, ay nasa left, L. Kani, right,
Ay, ang amino.
D. The same with our amino acid. Okay? This is on the left, the amino group, and then you have the right. So that is the Fischer projection. Now, amino acids can be described as non-polar, non-polar side chains. So you have here. Now, in your textbook class, there are some examples there of amino acids: polar, non-polar, acidic. Please read your textbooks. Page sa nagang.
Page 501.
501. Page 501. 500 to 501. Okay, there are so many, there are 20 types of amino acids. Now, amino acids can be essential and non-essential amino acids. What does it mean? Now, when we say essential amino acids, meaning they are present, they must be present in the diet. Okay? They must be present in the diet. When we say non-essential amino acids, meaning they may not be present in the diet. Why? Because our cells can produce these non-essential amino acids. Now, what are they for? What are these? Why is it that these essential amino acids must be present in our diet? What are they for? Now remember, in every activity of our DNA, that will produce RNAs and then translated into proteins. Now these proteins require, during protein synthesis, these require specific amino acids. And what are they? Where are they from? Now those essential amino acids cannot be synthesized by our body, and they have to be present in our diet. But of course, these non-essential, if they are already present in our diet, then the cell will not synthesize anymore. But all of these, whether essential or non-essential amino acids, they are all raw materials for protein synthesis. And that happens during translation process. So when DNA, like that one, when DNA is activated, then it undergoes transcription, producing RNAs, and RNAs will be translated into proteins, of which the amino acids are necessary as raw materials for the production of proteins. Now remember, proteins are the most abundant organic compounds in our body. So with that functions, they are very, very necessary. Okay? So you have here